Hello guys, welcome back to my YouTube channel. So today in this video, we are looking at the lead code problem which I am going to solve it. And this I have solved it before and I am making a video on it. So how you can solve and which algorithm you have to use, I will be demonstrating it over here. So yeah, let's start the video. And the question is container with most water. So this is the name given to the lead code problem. So let's read and understand how it is, and let's understand how we can find out the solution of this by writing the code, optimized code. So let's look at the question over here. You are given an integer array heights of length n. So these are all height which is given. This is first height. This is second, which is of 8, then 6. So this height is given to us. There are n vertical lines drawn such that the two endpoints of the ith line are I comma 0 and I comma height of I. Find two lines that together with the x-axis form a container such that the container contains the most water. So we have to choose one of the container which can fill lots of water. Maximum water can be filled. So in this, we need to find out the solution of this. So let's understand how we can write the code of it. Let's understand how the algorithms work for the for that problem. The problem which we are looking, which is container with most water. So here for this height, I will be taking one variable which is pointing it. I will be taking as L, and this height I will be taking as R. So I will be filling water over here. So water will be filled till 1 only. If I will be filling more water in this, so the water will come out. So this small height, this small height only I can fill water. Here, if there is more height, that is not useful for me because till this small height only I can fill water. So wherever there is small height, till there till that height only I can fill water. So here 1 and its 1 is its length and breadth is 8. 1 multiplied by 8, it is giving me maximum area which is 8. So I will be then changing my L. So which one was our smaller from these two? This was the smaller. So I will be shifting L over here. So now L is pointing to this height and R is over here only. So till this height, I will be filling water. So till this smaller height, the water will be filled. So over here, 7 is the length and breadth is 1, 2, 3, 4, 5, 6, 7. So 7 multiplied by 7, it becomes 49. So maximum area for this is 49. Next, we will be seeing which one is the having the smaller height. So over here, this one is having the smaller height. So I will be shifting R over here. So R is now over here. And this height is same. Once again, water will be filled until this much height only, the water will be filled. So over here, how much is the length? 3 and width is 1, 2, 3, 4, 5, 6. 3 multiplied by 6, which is 18. So maximum area is 18. Next, which one was our smaller? So this was the smaller. So our R I will be shifting over here. Now R is over here and L is over here. So which is the smaller height? Both are equal here, 8 and 8. So till 8 length water will be filled and width will be 1, 2, 3, 4, 5. 8 multiplied by 5. So it become area 40. So over here we can see both are having the equal height. So any of the R or L we can shift. So let's shift L only. So now our L is over here and R is this only. So once again the water will be filled. So it will be filled till this less height and its length is 6 and its breadth is 1, 2, 3, 4, 5. Now let me count it once again. 6 and 1, 2, 3, 4. 6 fours are. So here 3 will be not coming. Here 4 will be coming. 6 fours are. So it become 24. Okay. Because here 6 is there and here 1, 2, 3, 4. So it will be multiplied and the maximum area will be 24 by this. So we will be checking which of the height is smaller. So this is smaller. So our L will be shifted over here now. Now L is this. So here till 2 it is there and water will be filled over here. So here will be the width? Let me count 1, 2, 3. 2 multiplied by 3. So it becomes 6, which is the maximum area from this container. So from here we will be checking which one is the smaller height. So we are getting this one. So over here it is still 5 and water will be filled till 5 and the width is 1, 2. Then 5 multiplied by 2, which becomes 10. Okay. So now we will be seeing which from these two, which one is the smaller height. So this length, this L means it is left. This left is this bar is having the small height. So we will shifting our L to over here. Our left to point it. It will be pointing over here now. Now water will be filled. So it is 4 and the width is 1. 4 multiplied by 1, which is 4. So this all we have got the area and among this which one is the highest that we will be checking. So here 49 is the highest. So that will be giving us the answer which is 49, which we saw in the case test test case also that it was showing us 49. So this is the algorithm which we have to write in a Python program. So let's check, let's write it down quickly. So let's write the code for the discussed problem which I discussed. Let's write that. So maximum area. So first define DEF max area input will be height. Okay. And RES will be 0, which result which will be storing it. The maximum area will be there in it in RES result. We took two pointers which was left and right. Left was in the 0th place and right was in the ending part. Ending part means length of height minus 1. Okay. So our while loop we will be taking, and what will be our terminating condition? Well, length is less than r. At that we will be terminating it. We don't want to go. L shouldn't be going more than r, or it shouldn't be equal. If there is a L is less than r, till that time only we will be checking. So need to find area. In for area, this expression need to be written r minus L multiply by, and here will come minimum of height of L, comma height of R. Okay, this much is done. Area, from here we will find out the area, and we have to take maximum of it. So result from area, we will be storing it in result. Now two conditions, we have to shift our L and R also, right? If what will be our condition? If L is if height of L is less than height of R, then means height of L is less than a height of R. Then what I will be doing? I will be increasing my, I will be changing my L. So how? By increasing it by 1. Else I will be changing my R position. After that, I will be returning my result. Okay. Let's check for example 1. Height is given. Height is this much. Let's copy and paste. Okay. Let's call our function, define function, and pass height in that, and store it in our variable output 1, and let's print output 1. Okay, so over here it is giving us the correct answer which we found out over here. So this is giving the exact what we have discussed, that it is giving. Let's check it. There was other test case also. Let's see. Second test case is if it is giving us correct answer or not. Example 2, height is, I think 1 comma 1 is there. 1 comma 1 and output 2. This time I will be taking. Once again, function call, parameter is passed. I will be printing output and checking whether it is giving me 1. So yeah, so I have able to found out. So this is the code which you can write and get the maximum area. So here I have solved that. So this was the video which I was showing how you can solve this problem container with most water. So if you guys are having some other more optimized code, so you can share with me in my comment in the YouTube comment section. I will be checking all of your comments and let me know if other more optimized code is there over which solve this problem in an easy manner. I will be happy to see. And if you are liking my video and so please subscribe my channel and hit the bell icon so that you get notified whenever I upload a new video on it. And also share with the one who is solving the lead code problems and who are programming on the day-to-day basis. Let's learn with each other and grow with each other. So meet you in the next video then, and hope you are doing well, and bye bye, take care, and I will be seeing you in the next video. Till then, happy learning and happy coding.